So remember that at the beginning of this unit I told you that in order to solve a linear system, when you have two lines and then you're drawing them, there's three different ways that you can solve. And remember when we were solving, we're looking for that point of intersection. Remember?
Yes, POI.
Yes.
The POI. Okay. So remember I told you there's three ways that we can solve.
Yes.
We learned one. What did we learn? How did we do it? Graphically was one of them, right? Where we graphed the lines, we graphed both lines, and then we located the point of intersection. Do you guys remember that?
Yeah.
Last week? Now, we also said there's two other ways. So we said graphically, substitution,
And
elimination. That's right. So today we're going to learn the substitution. Okay? So the substitution, what does the word substitution mean?
Plug in some value somewhere.
Plugging something into something else, exactly, right? So if I want to, let's say if I have the pink plus the blue equals to the black, right? And I know the value of the pink, I can substitute that value in for it to solve my equation, okay? If I know what that value is, okay? So there is like a process that we need to follow in order to get to that solution. Remember that at the end, we're looking for a point, because even if you're doing substitution, you're looking for POI,
Yes.
right? So you're looking for a point that has Y value, all right? So at the end, you're gonna have to get that answer. So the value of X, the value of Y of that point. So, as you can see, I have the two equations. And in order to do substitution, you have to isolate a positive variable from either of the equations. So which means you're gonna pick one equation, and then you're gonna isolate for a letter, right? In each equation we have x and y, right?
Okay.
So we're gonna have to pick one letter in one of the equations to isolate for, all right? Now, the first thing I want to do is I want to label my equation. So this is equation 1, this is equation 2. Okay? Usually the one we pick, if available, we pick the one that doesn't have any number in front of it. So if you look right here, both x and y have a number,
Yes.
right? In the second equation, x has a number, but y doesn't have it. It has a 1 in front of it. Okay? So this is the easier one to isolate for. Now, if it's not like if there's no letters with no value in front of it, then you're stuck with that. Okay, you have to isolate. Pick one, isolate for it, try to do the work. Okay? Now, so I'm gonna isolate for y in equation 2. Okay? So I'm going to isolate for y in equation 2. What does the word isolate mean?
Eliminate.
Isolate means put it by itself. Leave it by itself. Okay? So if I want to leave this y by itself, what do I have to do? Bring the 4x to the other side. That's right. Bring the 4x to the other side. Okay? Now, that negative belongs to the y, right? So I have negative y equals to, what happens when I bring the 4x to the other side?
It becomes negative.
So I have negative 4x plus 5. Good. Now is y by itself, or does it still have something with it?
It has a negative.
It has a negative 1, right? Which is, it should not be there.
Yes.
I should get rid of it.
Okay.
Okay? Divide by
-1.
negative 1. Negative, right? To get rid of that. So I have to divide by negative 1 every single term so I can get rid of that negative. Are you okay with that, Alex?
Yeah, I'm keeping up a little bit.
Okay? So you see how this is a negative 1 right here. Oops. Right? So if I divide by negative 1, they cancel.
Alright.
So now I have y equals 4x
So that's
minus
-5.
5. Are we okay with this so far?
Right.
Okay. Now because y is by itself, what I can do is I can substitute the newly rearranged equation into the other equation. Okay?
Oh.
So you see how y is equal to 4x minus 5?
Right.
Yes.
Okay. If I take this value and place it in for y in the original equation,
Right, right.
then if you see, I would only have x's in there.
Yes, yes, yes. Right.
So look at this. So I'm gonna replace that y. I'm gonna remove the y, and I'm gonna replace it by the value of y, which is 4x minus 5. Do you see that?
Yes.
Okay. So I took this. So I took this and I replaced it in here.
Yeah.
Okay? So this way, if you look right here, I don't have y anymore. I only have x's and numbers, right?
Right.
So I can solve. Again, that y right here, I replace that value with the actual value of y, which is 4x minus 5. Okay? I'm gonna call this number 3, and I'm gonna say right here, I'm gonna say sub 3 into 1. Can you guys read that or no?
Sub 3 and
Sub 3 into 1. So basically I subbed in 3 into 1.
One formula. No,
Yeah, we took one into the other.
Okay.
Okay?
3x plus 8x minus 10.
So let's solve. So 3x, I have 2 times 4x and 2 times negative 5, right?
Yeah.
So I can distribute, so that's plus
8x
8x.
minus 10.
Mhm.
Equal to 12. X value is 2.
Now remember that, now I can collect like terms.
Yes.
What are my like terms?
3x and 8x.
3x and 8x. So like terms because they both have x in them.
You can add.
So that will,
Yes.
what can I do with that negative 10?
You can take other side.
Bring it
It
over.
will become positive.
Now why do I bring it over?
Yes.
Why do I bring it over?
X is already there and has a value.
I don't know what the value of x, I'm still looking for it,
Oh, sorry.
right? But I bring that 10 over because I want the like terms to be on the same side,
Okay.
right?
Yes.
These are two numbers, so I can have them together and I can add them.
How easy? X is equal to 2.
Now what do I have to do to find the value of x?
Divided by 11, both sides.
Divided by 11.
Both the sides.
Why divide by 11?
Just only x left hand side, that's all. You want to?
So, Alex, what do I have between the 11 and the x? What kind of operation do I have? Am I adding 11 plus x, or am I multiplying, or am I?
That's right.
Mary, I'm asking you.
That's right.
What's happening between the 11 and the x? Am I adding them? Am I subtracting them? Am I multiplying them?
I believe they might be divided from each other.
Is it 11 divided by x? Or is it 11 times x? When I say 11x, what does it mean?
11 multiplied by itself.
That's right. It's 11 times x. Okay? So, if I want to get rid of that 11, if I want to bring it over, I have to divide. Remember that?
Okay.
So it becomes 22 divided by 11. Because I'm doing opposite operation. You remember that?
A little bit.
Okay. So x equals to 2. So what I was doing here is I was isolating for x.
Right.
So I want to leave x by itself.
Okay.
In order to leave x by itself, first I have to collect like terms.
Right.
So I collected the 3 and the 8 to give me 11x. And then I brought the negative 10 over to become plus 10. Because I want like terms on one side.
Oh.
Okay? Now, to get rid of that 11 in front of the x, I have to divide because the opposite operation of multiplication is division.
Right.
So I end up with x equals 2. You okay with that?
Okay, so you, in layman's terms, you figured out the formula for y, and in order to find x, you required to add the formula into the x, then
Into the y? Yeah.
sorry, into the y, and then find the like terms, then calculate, then divide to
That's right.
find the value of x.
Yes.
My head hurts, but I think that's it.
It's a long process. So this is, we're almost done. Okay, so we found the value of x. But remember, in order to find the whole solution, I need to know the value of y. Because remember, I told you from the beginning, I need a point, which is x and y. Right? So if I know what x is, I can simply substitute it into that isolated formula and find the value of y. So I can do, remember the isolated formula is y equals 4x minus 5. Right? So all what I have to do is I have to plug in this value in for x. So that would be y equals 4 times 2 minus 5, which is 8 minus 5, which is 3. So my POI is 2, 3. Okay? Now, if I want to check my solution, what do I have to do? I know my POI. To check, what do I do?
Put the exact value in one observation.
In actually both.
Oh,
So I have to put the 2, 3
in both observations.
in both the original equations. I have to prove that the left side is equal to the right side for all of them.
Great.
Okay.
Okay? So, remember we did that even with graphically.
Yes.
So, 3x plus 2y equals 12. So I have to plug in 2 for x and 3 for y. So 3 times 2 plus 2 times 3.
6 plus 3.
6 plus 6 is
12.
12. So left side equals.
Left hand side is equal to right hand side. The second equation also like this.
I have to do exactly the same thing for the second equation. Okay? So I have to plug in 3 and 2. Or 2 and 3 into my second equation. Plug in 2 for x, 3 for y. So that will be 8 minus 3.
5 is equal to 5. Left hand is equal to right hand side.
If this doesn't work, if one of them doesn't work, that means I've done something wrong. Right? This must be correct. So left side must equal to the right side for both equations. Otherwise, go back and check your work. First thing you probably want to check here, make sure that you did not do any mathematical mistakes. But then if these are correct and you know they're correct, then go back and check your work. You've done something wrong. Okay? So don't forget to conclude your findings. So to conclude your finding that the solution or the POI is what? 2, 3. Okay?
Okay. The solving for the left and right bill is similar to something that we did before, except this time we don't have to do the graph, we have to do it through formula only.
Yep.
Okay.
Okay? So why is this called substitution? You see when we did this step right here, we isolated and then we plugged in this in for y. See this step right here?
Yeah.
This is called the substitution. Okay? I'm taking the y out and then I'm putting the 4x minus 5 in it. Okay?
Question.
Yes.
The method that you did here for the 4x minus the 5, they didn't really couldn't calculate each other because the 4 has an x value on it, right? That's why the 2 had to be used instead?
What do you mean? This one? This 2?
Yeah, I didn't understand that part.
You see I have a 2 here.
Yeah.
Where does this go? It has to stay there, right?
Alright.
It's only y that is equal to 4x minus 5.
Okay.
So what I did is I removed that y and I replaced it with 4x minus 5.
Oh,
So all what I did is I did switching. Okay?
okay.
You added the actual value?
Sorry?
You added the actual value?
I added the value of y with respect to x. Yes. Okay? I substituted. Yeah?
Yeah. I'll write it on slowly.
Yeah. So I'm gonna stop the video.